Assalamualaikum and good afternoon. Okay, today, last time we have learned momentum. Momentum is a product of mass time velocity. So today we are going to further to learn about principle of conservation of momentum. Okay, state the principle of conservation of momentum. So the principle said that the total momentum of the system will remain constant if there is no external force acts on the system. What does it mean? Total momentum before collision equal total momentum after collision. And this occur when there is no external force. For example, there is no frictional force acts on the system. So activity 2, our aim is to study situation involving principle of conservation of momentum. Okay, diagram shows two brothers are skating. The elder brother move and collides with his younger brother who is at rest. So what is their movement after the collision? So the speed of the elder brother will reduce, okay, atau decrease. The speed of the younger brother increase. Momentum of the elder brother decrease and momentum of the younger brother increase. Means that the momentum of the elder brother is transferred to the momentum of the younger brother. So as a result, the younger brother start moving. Okay, next. So flick a 20-cent coin A directly to another 20-cent coin B. So what happens to the motion of both coins after collision? So let's look at the video here.
1, 2, 3, 4, 5, 6, 7. 7 coins. 1. 1. Let us do it 2. 2. 2. 3. 3. And
Okay, so what happens to the motion of both coins after collision? So coin A will stop and coin B will move forwards. And now what happens to the momentum of coin A after collision? So momentum of coin A has been decreased because its momentum is transferred to coin B. Next, situation 3, we have 3 coins, so we flick coin A directly to point B and C. So describe the motion. So coin A stops, coin B stops, coin C move forwards. Now what happens to momentum of coin A after collision? So transfer to coin B and coin C. Okay. Now we have another situation. This is what we call Newton's cradle. Steel ball A is pulled and then released. So what happened after the steel ball A hits the steel ball B? Okay, let's look at this video. Okay, amazing, right? So what happens after the steel ball A hits the steel ball B? So ball A stops, ball B, C, D at rest. Ball E move outward with the same height as ball A. Is the momentum conserved? Yes. Predict what will happen if two balls A and B are pulled and then released. So as we see from the video just now, ball A and B stop, C at rest, ball D and E move upwards. Okay. Now we look at a simple or another situation. That is what we call collision.
Collisions happen when two or more objects come into contact with each other and a transfer of momentum and kinetic energy occurs. Collisions occur every time you hit a baseball, bounce a basketball, or play pool. When objects collide in the absence of external forces, they form a system in which the net momentum of both objects before the collision equals the net momentum of both objects after the collision. There are two types of collisions: elastic collisions and inelastic collisions. An elastic collision is defined as one in which no kinetic energy is lost, no damage is done to the objects involved, and there is no generation of heat. In the real world, no collision is perfectly elastic because so many other forces come into play, like friction, air resistance, and gravity. However, the game of pool offers a fairly good elastic representation. Pool tables and billiard balls are designed to reduce the effects of friction, resulting in close to ideal elastic collisions. When the cue ball hits the resting 8 ball, it sets the 8 ball in motion. Having transferred all of its momentum and kinetic energy, the cue ball comes to a rest. The net momentum of the cue ball before the collision equals the net momentum of the 8 ball after the collision. Momentum and kinetic energy are transferred and conserved. If the 8 ball is already in motion when a similarly moving cue ball collides with it, then the 8 ball will gain some of the initial cue ball's momentum, and the net momentum before and after the collision will be conserved. If the 8 ball and the cue ball are traveling at the same speed and collide head-on, then they will bounce off of each other with the same momentum, but in opposite directions. Their momentum and kinetic energy are transferred and conserved. The second type,
Okay, so let us
an
complete what
elastic
we
collision.
learned just now. So we have two objects, M1 and M2, collide together. So, M1 move with speed U1, M2 move with initial speed U2. Okay, motion of both objects after collision move separately with different velocity. Is the momentum conserved? Yeah, momentum is conserved. Is the energy conserved? Yes, energy is conserved. Is the kinetic energy conserved? Yes, kinetic energy is conserved. Now let us write down the equation regarding elastic collision. Okay, so before collision, M1 U1 plus M2 U2, and after collision, M1 V1 plus M2 V2. So equal because of the principle of conservation of momentum said that total momentum before equals to total momentum after collision.
Inelastic collision. In an inelastic collision, momentum is still conserved, but kinetic energy is lost in the system, resulting in the creation of heat and damage done to the colliding bodies. Bodies that are involved in an inelastic collision end up entangled with each other or stuck together. A clear example of an inelastic collision is a car crash. In order to understand the conservation of momentum in this example, we'll imagine a car crash taking place in a world where road friction and air resistance have no bearing on the system. Let's take two cars, A and B, with equal mass. Car B is parked when car A plows into it head-on at a velocity of 10 meters per second. Kinetic energy is immediately lost as the cars become mangled and stuck together. Some energy is converted into heat. Momentum after the accident, however, is conserved. With no road resistance, the doubly massive car wreck will continue moving in the same initial direction as car A, but at half the speed. The after-collision momentum is easily calculated using the conservation of momentum equation, where the mass of car A times its speed of 10 meters per second before the collision is equal to the mass of car A plus the mass of car B times the final velocity after the collision. Rearranging the equation to solve for the velocity after the collision gives 5 meters per second. Inelastic.
Okay, so what is inelastic collision? So two objects collide together and then after collision they will move together with the same velocity. Momentum still conserved, energy conserved, but kinetic energy is not conserved because part of the energy convert to heat energy. Now we write down the equation. So before collision, we have m1 mass of object m1, momentum m1 u1 plus momentum m2 times u2. After collision, both objects stuck together. So we have m1 plus m2 times v. So this will be the equation for inelastic collision. Okay, so let's look at an example of the collision. Okay, so that's it for today's lesson. So we will continue next lesson for another situation for using principle of conservation of momentum, that is explosion. Okay, see you next time. Bye. Assalamualaikum.